great demonstration of a three-group overlapping set question here. A lot of people really like Venn diagrams, and a lot of people push the Venn diagram. The official guide uses the Venn diagram. I honestly don't recommend the Venn diagram on these questions unless you have a lot of success with that. I'm never going to argue with your results. So if you're getting great results using Venn diagrams, then by all means, continue to use them. But if you're confused on these questions, if you feel like the Venn diagram's slow, or these questions are just not connecting for you with the Venn diagram, let me introduce you to my preferred strategy for these. I'd recommend memorizing this. It's just members of group 1 plus members of group 2 plus members of group 3 minus the sum of those people who are in exactly two groups. We'll talk about why that is in a second. We're also going to subtract 2 times the members of all 3 groups, and plenty of people have asked why. Why do we do that? Why do we have to multiply by 2? I'll explain that momentarily. Then we have to add in the members of none of the groups, and that should give us an accurate head count for the total people in the situation. Well, I just got done trashing the Venn diagram, but it is actually helpful for understanding the formula. But I think once you understand why the formula works, then it's probably time to ditch the Venn diagram, again, unless you're having great results with it. So let's say we're working at a company and there are 100 people working in the company total, and we want to get everybody together to socialize and do some team building. So we start a few clubs. Let's say we're going to start the sports club, the drinking club, and then the book club. And let's say 20 people are going to join the sports club, 30 people are going to join the drinking club, and 40 people are going to join the book club. Now here's where things can get kind of interesting, because if there are 10 people who are in the sports club and the drinking club but not in the book club, they're going to go here, but they're not going to go into the middle of the Venn diagram where all 3 groups are overlapping. Now, if we go around the circle and say there's also 5 people who are in the drinking club and the book club, but not the sports club, and then there are another 5 people who are in the sports club and the book club, but not in the drinking club, you'll notice that already if we add up these numbers, we're getting a number that's greater than the sum total of people. And you want to ask yourself, well, why? Why is that happening? And that's because these people right here, here, and here are all being double counted. They're being counted as part of the drinking club, and they're also being counted as part of the book club. And then in the case of these people are being counted as part of the sports club and also part of the book club. So when we're creating a formula that measures an accurate total of how many people are there, we need to subtract the people who are being double counted. And that's why we subtract these people, because how many times do we want to count them? If we want an accurate head count, we only want to count them once. And if they're being double counted, we want to subtract the double away. That's what gives us the accurate head count that we're looking for. Okay, but what if there are 5 people who are also in all 3 groups? So they're not just in the sports club and the drinking club, they're in the sports club, the drinking club, and the book club. Well, ask yourself, how many times are we counting those people? Well, they're being counted here, they're being counted here, and they're also being counted here. So those people are being triple counted. They're being counted 3 times. How many times do we want to count them to get an accurate head count of the total? We only want to count those people 1 time. That's why when we subtract the all 3 group, we multiply by 2 first, because we only want to count them once, but they're being counted 3 times. So we multiply by 2 to double subtract them and get them counted only 1 time. So I hope that clears up why that formula works. Feel free to reach out if you have any questions about that. Otherwise, let's dive into why this formula is so cool on a problem like this. Well, if you give the problem a read and you meditate on this formula for just 1 moment, you'll realize they're giving us quite a bit of information that helps us out. First up, they give us the total number of houses. Great, I can just pop that over here. Then they give me group number 1, which is 60% have air conditioning. Now, if you don't mind doing a little bit of percent mathematics here, you can just run the numbers. 6 times 15 is going to yield 90. Then they tell me group 2, 50% have a sun porch. Half of 150 is 75. So that's group 2. And then 30% have a swimming pool. That's going to be group 3. I'm a big fan of visual organization so that I don't make any mistakes. 3 times 15, that's going to give me 45. Okay, so that's A, B, and C. Okay, let's see if they give me the sum of exactly 2. It says next, if 5 of the houses have all 3. Okay, well, they're not giving me that, but they are giving me this. So let me go ahead and write that down. And then it says 5 have none of them, so we want to account for those people. In our previous Venn diagram situation, let's say 5 people don't join any of the groups. We still need to count them to get an accurate head count of the total, because if we just ignore them, then we're really only counting 95 people out of 100. But they're not being double or triple counted, so we can just single count them. Okay, and then the question is asking how many of these houses have exactly 2 of these amenities. Alrighty, and no surprises here that they haven't given me the sum of exactly 2 because that's what they're asking me for, and there wouldn't be a whole lot to do in this problem if they just gave you that. So let's pop a variable in there as a placeholder. I'll call it t for 2, and let's just run our numbers. Hopefully you can already see why I tend to favor this formula. They've given me so much information, I can really just plug and play. Let's do some addition over here. 90 plus 75 is going to give me 165, and then I'll add 45 to that, and I will get 210. 2 times 5 is 10, plus 5. And perhaps, obviously, you can run these numbers however you personally feel comfortable. Here, I'll think 210 minus 10 plus 5. That's going to give me 205 minus t equals 150. All right, almost home free here, so I'm just going to subtract 205 from both sides. And just so that I don't make a mistake at the end of the problem, which is really, really easy to do, I could for sure see myself doing something like 150 minus 205 is 45, because like it seems like the difference between 05 and 50 is 45. But that's not right, so I really personally like to be very careful about that. If you don't struggle with that kind of thing, that's fine. So I'm going to do some long subtraction, but long subtraction of a larger number from a smaller number just doesn't work out well. So what I like to do personally when I do this is do the larger number minus the smaller number and then just preemptively pop a little negative sign down there. And that usually works out great. So 5 minus 0 is 5. Can't take away 5 from 0 here, so I'm going to borrow from the 2 to make this 10. 10 minus 5 is 5, and 1 minus 1 is 0. And so there we go. Negative t equals negative 55. Let's go ahead and just finish this out strong and be one step closer to grad school. So if you like that approach, if this was helpful for you, give us that thumbs up. If you have questions about this stuff or anything's not clear, feel free to reach out anytime. And if you're looking for game-changing strategy and structure for your overall studies, just click the link anywhere around here and head to our website, and we will be happy to help. Talk to you soon.